NASA citizen scientists have recently discovered an object speeding through space at around 1 million miles per hour, known as Quaes J1249. This faint and fast-moving body may be a low-mass star or brown dwarf, pushing the boundaries between a star and a gas giant. What's truly intriguing is how this object was expelled from the Milky Way. It may have been ejected by a supernova or black hole interaction. In this video, we'll dive into this exciting discovery, explore the science behind it, and discuss why it matters. So, without further ado, let's get started. Using data from NASA's Wide Field Infrared Explorer WISE mission, which has been instrumental in mapping the sky in infrared light, citizen scientists Martin Kutnick, Thomas Blee, and Dan Seelan were able to detect this hypervelocity object moving at breakneck speeds. Initially, the object appeared as a faint blur across the screen, but upon closer examination and follow-up observations using ground-based telescopes, it became clear that this object was unlike any other previously discovered. It stands out because of its relatively low mass. It is difficult to classify the object definitively, but scientists speculate that it might be either a low-mass star or a brown dwarf, a so-called failed star that did not accumulate enough mass to trigger hydrogen fusion in its core. Brown dwarfs, although common, typically do not travel at such extraordinary velocities. In fact, while citizen scientists involved in the Backyard Worlds Planet 9 project have discovered over 4,000 brown dwarfs, none of them have been observed exiting the Milky Way at such a high speed. The unusual speed and trajectory of this object specifically suggest that it was ejected from a larger system through some form of explosive event, likely a supernova or a close encounter with a binary black hole system. Observations of its chemical composition further indicate that this object might be ancient, originating from one of the first generations of stars in the Milky Way, which is truly fascinating. The excitement surrounding this discovery is noticeable among the citizen scientists involved. Kutnick from Nuremberg, Germany, described his disbelief when he first saw how fast the object was moving, convinced that it must have been reported already. However, this discovery was entirely novel, adding to the mystery of hypervelocity objects and opening new opportunities for exploration and study. Hypervelocity objects are typically stars or remnants of stars that are traveling at such high speeds that they are on the verge of escaping the gravitational pull of their galaxy. These objects were first discovered in the early 2000s and are often linked to interactions with supermassive black holes, such as Sagittarius A*, the black hole at the center of the Milky Way. However, Quaes J1249 is unique in that it is a low-mass object, unlike the massive O and B-type stars that were initially found as hypervelocity stars. There are several hypotheses as to how this object gained such velocity. One possibility is that it was part of a binary system in which one of the stars was a white dwarf. As the white dwarf accumulated mass from its companion, it eventually exploded in a Type Ia supernova, launching the companion Quaes into space at an incredible speed. This scenario is supported by the fact that this object has a low metal content, suggesting that it is an older star formed in a metal-poor environment. Another potential explanation involves interactions with black holes. If this object originated in a globular cluster, it could have been ejected due to the gravitational interactions within a system of black holes. Such interactions are rare but have been simulated and shown to be capable of imparting the necessary velocity to propel a star out of the cluster and eventually out of the galaxy. This object offers a unique chance to study the chemical and physical properties of low-mass stars and brown dwarfs, which are usually too faint and cool to observe in detail unless they are nearby. However, with this velocity object speeding through the galaxy, scientists can gather valuable data that would otherwise be out of reach. This opens new doors for research into the formation and evolution of brown dwarfs and other low-mass stars, especially those from distant ancient parts of the Milky Way. Quaes isn't the only hypervelocity object. There were others that scientists discovered in the past years. For example, a brown dwarf named YSE also exhibited similar high-speed movement, although not as dramatically as Quaes. Ancient stars within globular clusters, too, have been observed to experience similar ejection processes due to gravitational interactions with black holes or supernovae. In addition to brown dwarfs, several hypervelocity stars have been observed. For example, in 2010, a star that starts with H was found traveling at an astonishing 1.6 million miles per hour and is thought to have been ejected from the center of the Milky Way. Similarly, two stars named Lamoste, discovered by Chinese astronomers, are also unbound hypervelocity stars, demonstrating the variety of objects experiencing such extreme velocities. But this raises a question. Is it possible that any of these hypervelocity objects could collide with Earth? The answer is that it's highly unlikely. Objects moving at such high speeds, like hypervelocity stars or brown dwarfs, are typically on trajectories that take them out of the Milky Way or through vast empty regions of space. Nevertheless, studying their movements allows scientists to refine models of stellar behavior and galactic dynamics. Finally, the role of citizen science in this discovery cannot be overstated. Projects like Backyard Worlds, Planet 9 illustrate how, with the right tools and guidance, amateur astronomers can contribute to groundbreaking discoveries. The identification of quays resulted from years of dedication by volunteers. This collaboration between professionals and citizen scientists will likely continue to yield exciting breakthroughs in the future, expanding our knowledge of the universe by broadening the scope of research into ancient stars and brown dwarfs. Discoveries like this one provide vital opportunities for learning more about the history and evolution of our galaxy. Thank you so much for watching. We hope you enjoyed learning about the exciting discovery of quays J1249 and the fascinating world of hypervelocity stars and brown dwarfs. The study of hypervelocity objects like quays J1249 is reshaping our understanding of stellar dynamics and the evolution of the Milky Way. These extraordinary entities are not just fascinating in their own right. They also serve as valuable clues to the processes that govern the formation and destruction of stars. Their discovery raises fundamental questions about the life cycle of stars and how they interact with one another in various galactic environments. One particularly interesting aspect of hypervelocity stars is their origin. Many of these stars are thought to have been born in dense star clusters, where gravitational interactions can lead to dramatic encounters. In such crowded environments, stars can be perturbed from their orbits, resulting in one star being ejected at high speed, while others remain bound to the cluster. This dynamic is further complicated in regions with a high concentration of black holes. Interactions with these massive objects can exert significant gravitational forces, propelling stars outward into intergalactic space. Moreover, the chemistry of these hypervelocity objects provides a deeper insight into the history of the galaxy. For instance, the low metal content observed in quays J1249 suggests it may have formed in a primordial environment where heavier elements were scarce. This can help astronomers piece together the timeline of star formation and the processes that led to the enrichment of the interstellar medium with heavier elements over time. Such knowledge is vital for understanding not only the Milky Way but also other galaxies and the universe at large. The ongoing exploration of hypervelocity stars is complemented by advances in technology. The development of more sensitive telescopes and imaging techniques has made it easier for scientists to identify and study these elusive objects. As astronomers continue to refine their methods, they are likely to discover even more hypervelocity stars, which will enrich our understanding of the processes that govern star formation and evolution. In addition to scientific exploration, the discovery of hypervelocity objects fosters a sense of community among amateur astronomers and citizen scientists. Projects like Backyard Worlds not only enhance our understanding of the cosmos but also inspire a new generation of space enthusiasts. The collaborative nature of these projects demonstrates how citizen science can bridge the gap between professional research and public interest, encouraging more people to engage with astronomy. As we look to the future, the potential for new discoveries in this field remains vast. Future missions aimed at exploring the outer regions of the Milky Way and beyond will undoubtedly uncover new hypervelocity objects, each providing a unique glimpse into the dynamics of our galaxy. Understanding the movement of these objects could also lead to broader insights into galactic formation, merging, and the influence of dark matter. The study of hypervelocity objects also has implications for our understanding of cosmic events. By analyzing the trajectories and velocities of these stars, scientists can gain insights into the dynamics of supernovae and black hole interactions, events that have profound implications for the evolution of galaxies. Such knowledge may even aid in predicting the future behavior of our own galaxy, including how it might evolve over billions of years. In a broader sense, the discovery of hypervelocity objects underscores the interconnectedness of all cosmic phenomena. Each new finding contributes to a larger tapestry of knowledge that enhances our understanding of the universe. As we unravel the mysteries of hypervelocity stars, we also confront fundamental questions about the nature of matter, energy, and the forces that shape the cosmos. In summary, the exploration of hypervelocity stars and their formation processes not only enriches our scientific knowledge, but also fosters a sense of wonder about the universe we inhabit. Each discovery, from Quaise J1249 to other hypervelocity objects, serves as a reminder of the dynamic and ever-changing nature of the cosmos. As technology continues to advance and more citizen scientists join the quest, we can look forward to an exciting future filled with new revelations about the stars and the complex interactions that govern their existence. The journey of exploration and discovery is far from over, and each step forward brings us closer to understanding the vast universe around us. If you found this video informative, be sure to like, subscribe, and hit the notification bell so you don't miss any future updates on the latest space discoveries. Let us know what other cosmic phenomena you'd like us to explore next. Until then, keep looking up and stay curious.